Welcome back to video number 3. Recall in the last video, we learned how to create the regression equation coefficients or slopes. And we also calculated the standard error. This is all and to be fair, we also created a confidence interval. Now, this is where it can get a little complicated because this is really the long way to do it, but I hope it provides some basic understanding. So I'm going to transition now to use a tool that comes with Excel, and that's called the Data Analysis Tool Pack. And in order to run that, it's much like Solver, where we have to go to File, Options, Add-ins. This may be slightly different on your version of Excel, so look for something that says Add-ins. Once you get to Add-ins, you can see the Data Analysis Tool Pack, and you can say Go. Actually, you can click on both of them here, or go back and run it twice. Once you get the check marks here, notice just like it is for Solver, then we can say OK. And notice that Data Analysis Tool Pack appears here. So if you missed it, we are starting with version B2, where we ended the second video. Although in this one I slid the two scatter plots with the regression equations down at the bottom here. And to make it work a little bit better, I'm going to delete row 23. Don't forget, we have that in our earlier versions should we need it. And I'm also going to do a freeze panes here. I think I did that in the previous video. Okay, that may help us. And now I'm ready to say, let's save this as B3. All right. So now let's see where we are. We've got our data. We've gotten rid of row 23, just note that. I reminded myself by leaving that in yellow. Here's the scatter plots. So now what I'm going to do is I'm going to recreate this regression equation, which we did here, a little bit more cleaned up format. But this time I'm going to use, under data, just like in Solver, the Data Analysis Tool Pack. So I click OK. And I slide down. There's a lot of things here. I'm not terribly happy with how they work. I would encourage you to explore, because this is not a costly package, but I don't think it's extremely clear in most cases. So I'm going for regression. The regression, again, is going to get complicated at the end of this video, or a little bit more complicated. So let's see how this works with something we've worked with so far. So now our input range is going to be from B1 down to B39. That's our Y range predicting price based on square feet, which is E1 down to, you guessed it, E39. Those contain labels. Again, there's a few more things here, but I'll leave that for the more advanced course, and I'll probably mention some of that in our summary video. If you just stay to this recipe, input range, output range, include the column labels, make sure you check labels here, put it in a new worksheet, so that should appear as a new tab down here, which I will label. And if you've got all that, you can at least create regression equations and take a look at them. Again, there's some weaknesses here, but it's free for everybody, as they say. So I say OK, and here's the output. And I'm going to label this output price by square feet. Trying to abbreviate a little bit. Now here, if I reformat this to currency, and we'll make 1 decimal, we can see, maybe I should make that 3 decimals. That's okay, we can do that easily. Go to the home, add a couple decimals, we see a little bit more accuracy. There we can see the $60 per square foot. Don't forget all the prices are in thousands. So there you see our regression equation. Here's your R squared value. Perhaps we'll bold that. Maybe I'll do some bolding to help identify the more important aspects here. So here's our R squared, and here's our standard error, which again, maybe I will format that here. And there you see about a $34,000 standard error. There's the coefficients. Now I'm going to add one more here. I'm going to reformat these p-values. Ooh, p-values. So let me format those cells to a number with 3 decimals. And we see that the p-values are very low. That's usually good. And if we recall from week 3, if P is low, HO must go. So what does that mean? And this becomes a fairly important aspect to regression. So we're really mostly concerned with the square foot coefficient or slope, whereas the y-intercept of about 86,000 is not as important, and that has very little meaning. But for the slope, so we're going to say hypothesis. We spell it right. For the slope, often called B1, keeping in mind that B2 could be another variable, which we'll look at in a minute. Hypothesis test for the slope, where HO is B1 equals 0, and you guessed it, HO is B1 does not equal 0. So I'll provide a little conclusion here. We reject HO because B1, because the P equals 0.P value equals 0.000, which is very low and less than any alpha we would use. Therefore, the slope for the square foot variable or square feet variable is different from 0, which means that square feet has a significant impact or influence on price, which we would expect based on, if we look at the, even just the scatter plots. Okay, I hope that was a good takeaway, because now we're going to up our game. That was pretty easy to do, I think. So now I'm going to go back to house price data, scroll up, and I'm going to create another regression model. I'm going to sort of, let's surprise that. So data analysis, regression, and remember what we wanted to do. We still are going to use the input range of B1 to B39, but now our output range of B1 to B39 for price, but now I'm going to include that second variable of lot size. So now I have 2 predictor variables that are hopefully going to help us better estimate price. So I say OK here, and look at the R squared. Let me bold that. That's how I'm so proud of it. It's almost 85%. And maybe we'll just label this one. This is price by square foot and lot size. and we compare that to here, it was almost 75%. Now we look at the standard error. Hey, we could format painter that. That was about 35,000. And now we've cut off about $8,000 in our amount of variation for our predicted values. Let me just make that column a little bit wider. Yeah, maybe even a little bit wider still. So we've got our standard error. And again, there's lots more here that I don't want to get into. I can format painter that for the coefficients. So we can see that the square foot is a little bit less. And now that the lot size is 46,000 for 1 acre. So a half an acre would cost 23,000 on average. So the interpretations are now the square footage is a little bit less, which makes some sense because we have a second variable to help us explain what's going on. So the square footage has a little bit less impact. The lot size is now introduced at 46,000, but don't forget, go back to the data. The lot sizes, pretty much range from 1/4 of an acre to, I think there was one big property in there. Yep, 2.5 acres. So based on that, at 2.5 acres, that means the property, just the lot alone, is worth over 200,000. I'm sorry, well over $100,000. I don't want to forget the p-values. I'm going to reformat those. Be a number with 3 decimals. By the way, the format they were in before, something called scientific notation. It's not a science class, it's an analytics class. Notice that the p-values are all still extremely low. If we go back to the original, let me bold that too. If we go back to the original house price data, we see that even though the R-squared value and the correlation between price and lot size wasn't nearly as good as it was for square footage, this analysis here tells me that it's pretty darn good. It's pretty darn good, and that is a great plus. So what we've got here is a second model that looks pretty good, and I'm not going to go any farther than that. So by adding a second variable, we were able to explain 10% more of the variation in price, and we were able to reduce our standard error by $8,000. And when we include that into a confidence interval like we did in the second video, we really can start to narrow that range. And is it good enough? Not quite yet, but we're getting there. Once the R-squared gets past 90%, then we start to see standard errors that get low enough to really help us. So we still have a little bit of work to do, but let's end this video at this point and pick that up in our final video.